Hi guys, welcome to part 4 of our final exam review for Math 171. We're now on question number 19. Clearly you can see it here. 1 0 is given and that 0 is -3 and our instructions are to find all the others. There are a lot of questions about finding the zeros of a polynomial function. So let's continue. We're going to use synthetic division, my favorite kind, and I like to make this really large L. Remember that you can make it look the way that it looks in the Pearson text, where it looks like a division. You also can make a little box and put a little line under it. The ways of synthetic division, because it is synthetic division, are multi-invariant. So however you best learned it is the way that you should do it. But of course in class, the way I did it was with a large L. Now outside here, we've got a -3, because that is the 0 that they gave us. And we've got these coefficients, and none of them are missing. How wonderful. There may be some missing in Pearson when we're doing our exam, so be mindful that this should be written in descending order, 3, 2, 1, 0, or no variable. So, and if there's any missing, you put a 0 as a placeholder. So 6, 28, 31, and 30. Bring down 6. Prepare to multiply everything outside of the big L, and everything inside just gets added straight down. So we get -18. This is going to give us a 10. Then we get -30. It's going to give us a 1. And then we get -3. And then we've got a remainder of 0, which is what we should have. If we don't get a remainder of 0, we've done something wrong because they told us it was a 0. 0 means that the remainder is 0. So these floating numbers mean something. 6 is our first coefficient, our variable is x, and our exponent should always be 1 less than the one we start with. 6x squared plus 10x plus 1. Now, 9 times out of 10, you will be able to factor it. But in this particular case, this is the 1 time out of 10, I don't think you can. So we should use the quadratic formula as the quickest way to find the other zeros. So our quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac. Ooh, forgive my handwriting, it's getting worse and worse. I should have typed this already. Divided by 2a. Now let's start plugging in. The opposite of b is -10 plus or minus the square root of 10 squared is 100 minus 4 times 6 times 1. That's -24 divided by 2 times 6. Alrighty then, so we've got -10 plus or minus the square root of 76. And we definitely need to check that with the calculator. And you should too. Don't think that you're the all-knowing, I know everything person. Maybe you'll make a mistake. I do it all the time. All right, so I'm going to come over here and make sure that that is the case. 100 minus 24, is that 76? It indeed is. Now, does 76 have any perfect squares in it that we could take the square root of? I like to start with the 4. So I divided by 4, and my God, 4 works. How did I know? All right, so we've got the square root of -10 plus or minus. Now underneath there, that's the square root of 4 times 19. And you know what the square root of 4 is. It's 2. 2 square roots of 19. I don't know the square root of 19, so leave that under there. Divided by 12. Now, all these outside numbers are even. So that means that they are divisible by 2. So divide the -10, the 2, and the 12 by 2, and we have our other zeros. And what are those other zeros written in these braces? It's going to be -5 plus or minus the square root of 19 over 6. Now, are you to do any other thing? Should you, write it separately? Do I include the -3? It said find all others. So since it already gave you one, it's not necessary that you put the -3 in there. So be mindful of that. You don't want to get any points taken off because you chose to do something extra. Don't be extra. Doesn't pay. All right, now for number 20. Find a function of least possible degree having real coefficients with the given zeros. Now we're cooking with grease. We've got radicals, oh boy, and we've got this 8i. How many zeros do we actually have? I want you to remember the conjugate pairs theorem that says if you have a 8i, you also have a negative 8i as a root. If you have a square root of 2, you also have a negative square root of 2 as a root, because they are conjugate pairs. Remember conjugates, especially, complex conjugates, are a plus bi and a minus bi. So if 8i is a root, then so is negative 8i. So these are our 4 roots. So our least possible degree should be 4. All right, now with each of these roots, what we do is we write x minus each one of them. X minus 8i, x minus negative 8i, which becomes x plus 8i. I'm just going to write it as a negative for the folks who might not have been paying attention and turn back and it's suddenly a plus. Double negatives become a plus. And then we have x minus negative square root of 2 and x minus positive square root of 2. No negative, there we go. X minus the positive square root of 2. Now, my advice to you is when you are multiplying these binomials, that you should pair up the ones that have i's and pair up the ones that have radicals, because it'll save you a lot of headache. You don't want to get all these middle terms with i's that will eventually cancel out, but if you just pair these i's and pair these radicals together, your life will be easier. So we're going to pair these two together first. And I want you to notice something about this pairing. They represent a difference of perfect squares. A minus b and a plus b, that's the factored form of a squared plus b squared. That's what we have here. So if we multiply x times x, we're going to get x squared. We multiply x times 8i, we get 8ix, and then negative 8ix. So they're going to cancel out. I'm not a big fan of writing down stuff that cancels out, but let me show you. 8ix minus 8ix. Again, I don't want to skip anybody for those in the nosebleed section that aren't really watching this. Negative 8i and positive 8i make negative 64i squared. Remember what I squared equals. It equals negative 1. All right, so the middle terms are gone. And since that equals negative 1 times negative 64 makes a positive 64. So we've got x squared plus 64. Easy peasy lemon squeezy. I hope. All right, on to this one. X times x is x squared. X times the negative square root of 2 is negative x square root of 2. Positive x square root of 2. Notice they cancel out. They're a difference of perfect squares. They've got to cancel. There's nothing in the middle. And then square root of 2 times negative square root of 2 is a negative 2. So that's x squared minus 2. Suddenly, we're looking at something real nice. 2 binomials that we can easily multiply that have no i's and no radicals. That's what we want. All right, so x squared times x squared is x to the 4th. If you need to make a box to multiply this, have no fear. Make your box. Take your time. X squared times x squared is x to the 4th. X squared times negative 2 is negative 2x squared. 64 times x squared is 64x squared. And 64 times negative 2 is negative 128. You can always check that in the calculator. Do not trust your mind. It lies. All right, so x to the 4th, negative 2 and 64 make a positive 62x squared minus 128. That's all she wrote. Ta-da! Function of least possible degree, real coefficients. These are our zeros. Let's move on to 20.